Here's a look inside a completely torn apart turbo that back in its day was probably very, very expensive. Yeah, this thing is pretty much destroyed because of some kind of glass, either viewport or ion gauge failure. It sucked a bunch of glass in, and that was pretty much the end. This thing's over 20 years old, but we'll go through all the components and kind of how it goes together. It's a pretty neat piece of engineering. It's amazing that they can even make these things, because this spun at about 48,000 RPM at full speed, which is, you pretty much have to have everything balanced perfectly to be able to do that. This flange here with a valve attached, but it's an 8-inch flange to a 2.75-inch reducer, which will be really useful for the chamber. Definitely going to use that guy. It's a shame that the turbo is broken, but that's all right. Get to take a look inside here, and you can see, so when I first opened it up and looked into the top, all I saw was these the rotor blades, and then this screen which sort of sits in the top, and this doesn't let big pieces get into the turbo, but it had a bunch of little glass shards on it, and then you could hear them sort of dinging around inside the turbo if you turned it. And I'm guessing what had happened was there was some kind of a viewport or maybe ion gauge failure, and it just sucked it right into the turbo, and that was the end of the functioning turbo. Let's see if I can get a little closer to show some of the blade damage here. Let's see. It's kind of hard to see here. Yeah, there's one. You can kind of see the nicks in the blades, and there's a good one. And yeah, they've got them going to like the 3rd and 4th rows as well. There's just a bunch of damage on the blades. So the way these things work is the turbo opening is up here, and you have all these stages of blades, and it basically spins very, very quickly. The nominal speed for this thing at full sort of operation capacity is about 48,000 RPM, and it will hit molecules and force them to go down this way, and then they get sucked out through the backing pump. And so each of these blades are angled in such a way where as they rotate, they ping pong the molecule back and forth all the way down the pump. And the other piece of this is these are the stator blades, meaning they're stationary, they don't rotate. And the way this thing gets put together is you have in between each rotor blade, you get one of these stator stages, and they kind of look like this. So it's got a this is a maglev pump, so it actually levitates. When it's operational, the rotor is levitating with magnetic control, so that way there is minimal, basically no friction, but because of that it has to be actively controlled to keep that levitation going perfectly. So it's got a few electromagnets in there, one axial to control the up and down levitation, and then two radial to keep the shaft centered. And it's got radial and axial feedback, so it's constantly controlling this thing, which it's great because it's less maintenance. You don't have to deal with oil, but if that control fails, it will crash this thing. It's got the controllers have some safety built in and batteries and whatnot, but it is much more sort of active management system than the standard oil bearing, whatever pump, kind of mechanical bearing, I guess you'd say. So this thing basically unscrews from the top. Well, technically this is the bottom. I've got it turned upside down right now. And this comes right out. And so here's part of the bearing assembly. So the actual, you can kind of see the ball bearing here. This is what they call a crash bearing, or not a crash, sorry, a touchdown bearing. So if for whatever reason during operation this thing fails, the control fails, and this is like a backup bearing to allow the thing to basically touch down at full speed and spin down without totally destroying itself. And these will, if that happens a couple of times, these do go bad, and then you have to replace them. So this comes off. So here's one of the touchdown bearings, and also this is built into the axial electromagnet. So this is the electromagnet that controls kind of how high the shaft sits as it's rotating. Here's the other part of the touchdown bearing. So you get one at the top, one at the bottom, and all of this is the potted in. You've got the motor drive in here, which I'll have to count these, but it basically just takes in three-phase. There's the 3 wires. It's driven with three-phase modulated DC, basically, from the controller. I think the nominal voltage is like 45 volts, I want to say. Actually, I'm not sure if it's modulated DC or if it actually gives it a nice sine wave. But I am going to try and drive this actually, just to see if I can make it rotate with a three-phase brushless DC motor controller. Yeah, it's got, I don't know if you can see, but it's got multiple poles in there, as you would expect. Probably 12 pole, something like that. Let's see. Yeah, so it's a 12 pole motor. And then up top, these are the radial electromagnets that control the tilt of the shaft as it spins. And then there's feedback sensors, so it's actively sensing where that shaft is, and that's where all these thin wires are for, because there's really only three wires needed to drive the motor. Sure, these red, white, and black ones, but everything else is for the active magnetic levitation control. And you've got a couple at the bottom here to drive the axial magnet, and then this piece has the axial position feedback, so that this is the kind of the bottom cap caps off. So I'll show you how this thing looks, and then the shaft attaches to the rotor blades up top here with these 8 screws. Yeah, so let's see what the easiest way to do this. Here's the bottom piece, and this is where your backing pump connects for the turbo. This is where the control, basically the power cable and control cable plugs in. Here's what the connector looks like. It's, let's say, like 24 active pins, something like that. Okay. So the coil housing goes on top. Get your here's the axial magnet along with the bottom touchdown bearing. This top piece goes on like so, and then this cap screws on, bringing it all together. And then this sits in here in the bottom. Base piece, and then this all gets sort of capped off. Like so. And there's some bolts that attach this bottom piece because it's magnetically pushed away right now, and then the top the bottom cap that sort of brings it all together here like so. Then we can turn this thing back upside down, or right side up as I should say. And so now it spins quite freely. Now with the base installed, I can show you how the stator blades go on. So you put the bottom ring down for the last stage down here, and then these two guys. Basically just like that until you have all of them put in. You just go on one by one. You can see how smoothly this thing rotates just sitting on the touchdown bearings. It's very precise precisely engineered and machined parts. These things are kind of amazing. All right, so I'm gonna remove the stator blades and put on the housing just to show you kind of what the pump would look like in a normal state. Pump housing just goes right over the top, and you can actually kind of see the sealing O-ring down here. Gets fixed in place through some bolts, and then that's basically what it'll look like. Obviously with the stator blades it'll look a little bit less open in here, but yeah, and then the sort of debris shield, I guess, goes in the top like this, and that's it. That's what it would look like before being completely torn apart. Yeah, this thing, it's a shame that it's destroyed, because this would have been a really nice turbo addition to my little guy over there.